In this video, I will show you how I tested my windows for excessive air infiltration, testing that my home builder said doesn't exist. The first thing I did was use plastic sheeting to seal up the inside of the window. I did this by applying masking tape all the way around the trim and then installing double-sided foam tape over that. The plastic sheet is then stuck to the tape, taking care to ensure it is sealed. You can see that the plastic is inflated. This was so much of a surprise that I went outside to check that the windows were closed. Yep, closed. Here's an external view of the inflated plastic sheet. You can see it pushing back to its inflated state when the hand is removed. So what's going on? Well, it was a relatively windy day and I forgot to measure the wind speed, but Weather Underground archives show historical records to be 15.9 miles per hour winds with gusts of up to 22.8. Now, depending on where you live, you may call that a windy day and that would be your subjective opinion, but let's try to stick to what we can quantify. The Beaufort wind scale was one of the first scales to estimate wind speeds and the effects. Admiral Sir Francis Beaufort developed the scale in 1805 to help sailors estimate the winds via visual observations. The scale starts with 0 and goes to a force of 12, as recognized by NOAA. The Beaufort scale is still used today to estimate wind strengths. So, as you can see with your newfound perspective, it was just a moderate to fresh breeze. I cut a 60mm hole in the sheet to match the bore diameter of my anemometer. Placing the anemometer up to the hole, the air velocity can be measured passing through the hole. The units are in feet per minute, which can then be used to calculate volume per minute, as we know the hole is 60mm in diameter. Here's the math. The air leakage through the closed window at the time of testing was 9.57 cubic feet per minute, or enough to replace 100% of the air in the room in just 3 hours and 50 minutes. This video illustrates the air movement. Watch the flame. The 60mm hole was a little big. I thought, what would happen if the hole was smaller? Think about water flowing out of a hose. Then you stick your thumb over the end. What happens? The velocity increases because the same volume now tries to pass through the smaller hole in the same duration of time. That's exactly what's happening here. The velocity has increased and it blows out the flame.